This is the Runcam 5 orange, but why do I have two eyes running behind it? That's what we are going to see in this video. So, a couple weeks ago, Bardwell had posted a video explaining PIN-IO function and how to set it up for a naked GoPro and Insta360 Smoke 4K. Then I thought, why not implement it on my Runcam 5? I am a female and we are gonna mod something today. So today in this video we are going to control the Runcam Action 5 camera using an AUX switch on our controller. Before going into the step-by-step procedure, I will give a brief explanation that will help you understand what's going on. If you hate explanations, then you can just skip into the procedure straight away. If you are having a Runcam 5, then you may know that we only have one button that is used to start or stop recording or to turn the camera on or off. So long pressing the switch turns the camera on, and if you short press it, then it will start recording, and to again stop recording you have to short press it, then long press it again and it turns off the camera. Because we are having only one button, the camera's microcontroller just measures the time the button is pressed, and based on this time the camera decides the corresponding function to be performed, that is, long pressing corresponds to on or off and short press corresponds to start or stop recording. In our case, we have a 3-terminal switch whose middle pin is at 0 volts, and these two pins right here are at 1.7 volts each. And what happens is, when you press the switch, a physical contact is made between the middle pin and the adjacent pins. So what happens is, this 1.7 volts is now pulled to 0 volts. So if you are thinking, oh, this is a short circuit and will damage the circuit, but it's not. So what will we have right inside our microcontroller is this kind of arrangement. So internally there will be a resistor connected to the 1.7 volt pin. This resistor is known as the pull-up resistor. It will be connected internally, and then the voltage across this point is measured by the microcontroller. So whenever we have this 1.7 volts right here, and when the switch is open, then there won't be any current flowing. So this point will be at 1.7 volts when the switch is open. But as soon as you close the switch, what happens is, a closed circuit is formed and the current starts flowing through the resistor, and we see a 1.7 volts drop across here. So all the voltage drop across this point, and what we are going to see is 0 volts here. So this point is voltage at this point is measured by the microcontroller. So what we'll have is the microcontroller will decide 1.7 volts as a logic high and 0 volts as logic low. So based on that, this microcontroller will decide, and the time for which the switch has been pressed, the microcontroller can now decide which function to perform, either to start or stop recording or to turn the camera on or off. Okay, so we have a 3-terminal switch on our action camera and a microcontroller too, and we have our FC. So what we are going to do is solder up a wire to left pin or the right pin of the switch and take it to one of the UART or LED pads of the flight controller, and then what we are going to do next is take up another wire and solder it up to the ground pad of the action camera and connect it to the ground pad of the flight controller. What this will do is, make the microcontroller board and the flight controller at same reference potential. So whenever we bring this pad to 0 volts, then the microcontroller and action camera will assume that the switch is being pressed and will perform the corresponding function according to the time that the 1.7 volts is brought to 0 volts. To make one of the UART pad as logic high or logic low state, what we have to do is we have to implement pin box function of the flight controller. Pin box can make the input or output pins of the flight controller to be at logic high or logic low. So if we connect a wire that we soldered to the switch and connect it to one of the input or output pads of the flight controller and configure the pin box such that whenever we press AUX switch, the input or output pad will go to 0 volts, that is logic low, and if we release it, it will become logic high again. Now this will simulate the physical button press happening on the action cam. Coming on to the procedure part, you need to remove the top screws carefully. These are star shaped screws, so you need to have a star head screwdriver in order to remove those. And the next thing is to drill a hole into the back plate of the action cam. Be very careful while drilling holes. As you can see, the hole is nice and clean. Here you can see I have both the wires coming out of my action cam. Since I was testing it, I had them soldered already, but I will show you how and where to solder them. You need to carefully open the first PCB board. Make sure not to damage any other components while removing it. And as you open it, you can see the second set of screws that are ready to be removed using a flathead screwdriver. So you remove those screws, store them carefully, remove the SD card, store that too carefully, and after that what you need to do is carefully separate the front PCB. You need to be very careful since flex cables will be running around. Here you can see the switch with 3 terminals on it. This is the switch we need to solder our wire to. You can choose to solder on any one. So long pressing it turns on, and again long pressing it turns the camera off. So there will be 3 terminals on this switch, and you can switch either left terminal or the right terminal. Make sure to not make contact with the middle terminal of the switch. So carefully run the wire through the middle section of the PCB board so that you are not touching any other components. So the second PCB board, on the bottom side you will find the negative pad. This is the ground pad of the action cam. As you can see, I have soldered the second wire to the negative pad of the PCB, and I run it carefully along the bottom PCB board, and make sure the switch is pressing. Now tighten up the screws of the second PCB board and close the top PCB board. Make sure to run the wires in between of the 2 flex cable. Press it down carefully, and then run the wires through the back plate and screw them on. 1.71 volts, and shorting it will turn the camera on. Insert the SD card, then check back on. It should turn on. Short pressing it should start recording. Again long press to turn off. These are some few jumper male terminals, soldering it to the wires, and then we'll heat shrink it to make them more secure. It's nice and clean. This is the TX3 and RX3 and TX4 RX4 S bus pad right here, and LED pad on the FC. In my case, my TX3 and RX3 are used for crossfire receiver, TX4 for smart audio. So that is the S bus pad right there. It's correspond to TX1 and RX1. And LED pad is right there for you might wanna use the S bus pad if you want. Since I am using only crossfire, I have the UART one not being used for anything, but for demonstration purpose I am going to use just the LED pad for now. So we'll use the LED pad and the ground pad. And I soldered this female jumper so that while connecting the camera it will be easy. Coming on to the controller, we need to go to the model settings, and then in that we're going to mixes and assign the SH AUX switch to channel 5. If you don't know, in Betaflight channel 5 corresponds to AUX 1. So this might here be buzzer pad. You might want to switch to other pad if you like, but for me this SH pad is okay. So configuring the source to SH, then hit return, and we are good to go. Coming on to Betaflight, we will type dump all in order to save our previous settings. Then save it to file. You can save it to any file location that you want. Then you're gonna type default and save this to file. Then clear the output history and type resource. Since I am using LED strip pad, so I'll be using for LED strip 1 and the corresponding pin is A00. We'll take note of that, not the any other LED, only the LED strip pad. So we have to type the next command as set pin IO equal to 40. 40 corresponds to user 1 on the modes tab, so set 40, and the other modes will be off, so 255, 255, 255, and then type save. Be careful, don't just click on save. You should type save. No. And in the modes tab you should see user 1, add range, and it's AUX 1 switch, so set the range, and then hit save. The things here you can confirm by pressing the switch on and off. Go to CLI, type in resource and LED strip. This will free the A0 pin that is assigned to LED strip pad. So LED strip is none. So A0 pin is now freed, and we will assign this to our user 1. So resource pin IO, it's 1 for user 1 and A0 pin, and then type save. Okay, final check. Plug in the battery, turn on the transmitter, take a multimeter, and if you check the LED strip pad, after the receiver is on, you should see 3.3 volts, and when you flip the switch, it should go to 0 volts, not the other way around. So that's it, it's working fine. Now we connect our ground to the ground pad of the FC, and this 1.73 volts to the LED strip pad. Flip the switch, should turn on. Short press, start recording. Again a long press, it should turn off. There you go.